more near-Earth object asteroids. Apollos orbit mostly between the Earth and Mars, but they can actually cross Earth's orbit, again, as this one does. First one was discovered also in 1932. We know of about 3,200 of these, and about 300 of those, again, have been discovered this year. It's because there's some automated searches going on that I'll mention later on. Other named examples of Apollo asteroids are 25143 Itokawa. You're going to see a picture of it later on in the presentation because a Japanese probe flew by it and took a close-up picture. And for those of us of a certain age, there is an asteroid named Syrinx, which I really wish were number 2112, but it's actually number 3360. Sorry. That's going to mean a lot more to some of you than others, I know. And then finally, there are the Atoms, which are even closer in, named for number 2062 Atom, discovered in 1976. And they're usually closer to the Sun than the Earth is, but they can cross the Earth's orbit. Also, over 500 of those are known, and at least 30 of those were discovered this year. The most famous Atom asteroid by far is Apophis, which was discovered back in 2004. Its initial designation was 2004 MN4. It got to a rating of 4 on the Torino scale, which I'll explain a little bit later, because it was thought that it might hit the Earth in 2029, on Friday, April 13th, 2029. We now know that it isn't going to hit the Earth, and one of the reasons we know that is that some observations done in the Astronomical Society of Kansas City helped to refine its orbit. Okay, so how many asteroids are there? Well, it depends on the size. There's a few large ones, there's a moderate number of medium-sized ones, and there's lots and lots and lots of little ones. And this kind of distribution is called a power law distribution. And this is the driest and most mathematical slide in the entire deck. The thing to take away from this is that for every time the diameter shrinks by 10 times, there are 200 times as many of them. And in order to really bring that home, I'm going to do a little sort of kinetic demonstration here. And I've threatened to do this a couple of times on previous talks, and I've never actually done it, and I didn't go to full scale this time. The original plan was to do a, yeah, that's the only one can take it. The original plan was to do a beach ball and 200 ping pong balls. We're going to do one. This is some kind of bouncy thing that I got at Walmart today. If you can't, you can just keep it. We'll just make it a door prize this time. It's not like the props are real expensive. But I'm going to throw this up, and we're just going to see if it hits anybody. Okay? So we'll do this. Didn't quite hit anybody. Hit between a couple of people. All right. You know, the really fun thing about this is that did I not get permission to do this? I didn't even tell these guys I was going to do this earlier, so they had no idea this was coming. Okay, so anyway, let me get this thing open. All right. Now, what I wanted to do, you know, originally was like a beach ball this big, but believe it or not, beach balls aren't on store shelves in October. And then I was going to do 200 ping pong balls. 200 is a little pricey, so I got a pack of 36. All right, no ducking. Okay, that hit a few more people. In a future version of this, we may have something that actually shoots the ping pong balls so that, you know, we can do this. But anyway, the point of that, of course, is to get the idea that the much larger number of smaller ones are the ones we really want to worry about. The ping pong balls, not the whatever the heck that other thing was that I threw. And interestingly enough, the ones that are about 10 meters in diameter, that there are 40,000 of for every one of these. And remember, there are at least 1 million of these to begin with. So multiply that by 40,000, and you get a nice large number. If one of those hits us, it's going to have an impact energy of around 23 kilotons, which is just about what the atom bomb that destroyed Nagasaki was. So that's just kind of something to think about. And yes, that's a hint of what's coming later in the talk. Okay, historical impacts that you've heard of. Perhaps not by these names, but Chicxulub's the dinosaur killer. We now think that may have been about a 10-kilometer diameter fragment of asteroid 298 Baptistina. The crater's 180 kilometers across down in Yucatan. And Barringer, which is also just known as Meteor Crater in Arizona. That was a nickel-iron meteorite about 50 meters in diameter. Impact energy was about 2.5 megatons. That crater is 1,200 meters across and 170 meters deep. And I think everybody's heard of Tunguska. The centennial of it was last summer, not the one just passed, but 08. And of course, these are artist conceptions here and here. But that's an actual photograph taken about 20 years after the event. I think there was an early Soviet expedition out there. We don't know really what the impactor was. It could have been cometary, it could have been a stony meteorite that exploded at altitude. The impact energy was about 10 to 15 megatons. They've never positively identified a crater. Fortunately, all of this is about 1,000 kilometers north-northwest of Lake Baikal in Siberia, so very few people even saw it. Would have been a little different if it had happened a few hours later and, say, taken out St. Petersburg. Notice that was an airburst. Going to talk more about airbursts later in the talk also. Some craters you can visit, and the reason I mention these three is simply because I've been to all of them, and they are pretty easy to get to. This is a map that shows the impact craters that were known in North America as of a few years ago. There's probably more than that now. Of course, we know of others all over the world, and we're beginning to find them on the seabed as well, and I'll mention one later. Decaturville is just south of Lake of the Ozarks on State Highway 5. It's in Camden, Lebanon. It's about 3 hours away from Kansas City. Odessa crater is just a couple of minutes off I-20 out in West Texas. There's a visitor center there that you can go in, and you can actually walk around in the crater itself, which is kind of fun. It's not a real spectacular crater anymore because it's had West Texas sand blowing into it for thousands of years, and now it's only about 6 feet deep. But it's fairly large, and you can certainly tell it's a crater. And then Sierra Madera is actually the central peak of a much older crater in south of Fort Stockton on US 385. I mentioned that again. I've been there. It's possible to get permission from the landowner. You hop a fence, climb up into these hills, and start picking up rocks and breaking them open with a hammer, and you will find these little patterns in them called shatter cones, which are produced when a very high intensity shock wave goes through the rock. The only things that produce shatter cones are asteroid impacts and nuclear bomb tests. Okay, let's see. But the very closest one that you can get to, and one of the newer discoveries, has the wonderful name of Wobblo Osceola structure. And it's a couple of hours southeast of here. It may be one of a series of impacts along the 38th parallel. We're not completely sure of that. That would have been something, if true, like the Shoemaker-Levy 9 impact on Jupiter in '94, where it was a comet, broke into a bunch of pieces. It was linear. They all just hit one after the other. It could have been something like that. If you've ever driven along Missouri State Highway 13 between Osceola and Collins, you've gone right through it. If you've ever been to Barlow Scout Camp, I think it's about there. Leo, is that correct? Am I getting it approximately right? Cool. See, I backup laser. Let's see. It's the fourth largest in the United States. It's one of the largest on Earth. The subject matter experts on this are Kevin Evans, who teaches at what is now known as Missouri State University in Springfield, and we've got a guy in the ASKC who lives near Osceola named David Neuenschwander, who's kind of our liaison down there. And there's little field trips and hikes and stuff down through there all the time, if you ever want to know a little bit more about it. Okay, some impacts that you haven't heard of.